Hi. Yes, you're reading that correctly. This says daily lessons 158 through 167. That's a whole lot, but most of the time we're just going to be drawing rectangles and maybe some trapezoids. So I'm hoping it's not too bad. As always, flip through this video as needed. My objective for you is to learn the material, and if you just are like, yes, I get the point of this, I understand it, and move on, do that. You can always flip through. There's no penalty for doing that. I just want you to understand it. So ask me questions as needed, but also skip through as needed. Okay, so in here, this is Riemann's sum. So we were just talking about integrals. We're still talking about integrals. This is really little. It used to be on the other side of the page, like it used to be in a landscape view, but we're going to keep going with it right now because this is what you have. So I didn't want to do it in some other form. So a Riemann sum, this is a graphical approach to the definite integral. So just like before we would have an equation and then we would go to a graph and then we would have a table, we can do the same thing here, even though we're talking about integrals. So here it says calculating a Riemann sum. We're going to learn more about that. It's a way to estimate the area under the curve. So if we have a weird shape like this is not a shape we know. We're going to use this new method to find the area under the curve. And when I say under the curve, I actually mean between this curve and the x-axis. We just say it's under the curve. So in this activity, we'll learn how to calculate 4 types: a left, right, midpoint, and trapezoidal. That's why there's so many pages, but hopefully it'll go pretty quickly. Here it says consider this function, f of x. That is what's given here. So this is f of x. So if you want to label this. The graph of this function is below, and that's the same thing. This same graph is over and over again on every page from here to 167. On this interval from 1 to 7, so I'm only going from 1 to 7. So the area that I'm really trying to find is this in here. So from 1 to 7, if I were to shade this super lightly, because I don't want to mess up the next thing that I'm doing, this is what I'm trying to calculate. But this is a shape unlike any that I've seen before. This isn't a circle. It's not a rectangle or a trapezoid or some other shape that I have a formula for. So we're going to try to calculate the area of this shape. The way that we're going to do that is we're going to integrate. And what I'm going to do is I'm using this method of Riemann sum. This is just an estimation. And it says rectangles of 2 units. So this first one that we're doing is a left-hand Riemann sum. And so we're going to make rectangles, but I'm going to go up on the left-hand side of a rectangle. So from here, and I'm going to go up until I get to the left top-hand corner. Sorry, it's hard to write like that. There we go. The left-hand corner of my rectangle is going to touch this line. So it's going to touch the function f of x. And then a rectangle has to have parallel sides, and down here at the bottom of it, if I say of 2 units, that's what it's asking up here, I'm making a rectangle that has a length of 2 units and has a height of f of x. Over here, I can't just go up. I would have to just go straight over. So I'm filling in that shape. So I found the first rectangle. Here, if I did it for a second one, I'm going to use this, go the whole way up until I get to the top function. This is a left-hand Riemann sum, so the top left part of my function, that's where I'm going to determine the height. And then I'm going to do one more, because this is a length of 2 units. I'm going to go up till I get to here. And you might be saying, this looks nothing like the shaded region, but it is an estimation for the shaded region. So what I'm finding is I want to find the area of this part plus the area of this part plus the area of this part, because I know how to find the area of rectangles. So I'm just starting off really basic. And the way that I'm going to do that is I'm going to say, well, this would be the length times the height, or you could say the base times the height. This is just 2. My height is going to be whatever my function value is at 1. In the next one, I'm going to say my width or my base or whatever you want to call this is 2. My height in this case is f of 3. Over here, I'm going to say plus 2. My height is going to be f of 5, the function value at 5. Because all of these I'm trying to find, well, the height would be the y value, the function value at 1, 3, and 5. And I'm going the whole way to 7 over here, but the last height of my rectangle is at 5. So I'm stopping there. Now I need to fill these things in. I could factor out a 2 because that's the same. So I can say 2 times f of 1 plus f of 3 plus f of 5. And then f of 1, I found this before, but you can substitute back into here and figure out that f of 1 is 20 over 3. F of 3 is 8. Oh, sorry, I did this weird. Yeah, I'll just put another parenthesis. Plus f of 5 is 20 over 3. Because I've done this before, and if you don't believe me, just go up here and substitute in 5 into f of x. 20 over 3 is almost 7, and you can see that this at f of 5 is almost 7. Okay, feeling good? Go. If I multiply all these things, I would get 128 over 3 because I've done this before, or that's like 42.667 square units. And we're going to come back to more of this, but for right now, and understand what these integrals are and how integrals relates to this, because right now it doesn't look like it all. It looks like we're just doing area, and that's okay. This is the space we're in right now. So we're trying to take the area under the curve, which I said was just this region. You can see it's a little bit darker right here. And I'm estimating it by doing the area within each of these boxes. And I got an area of 42.667 units of some sort. Square units probably. It would be whatever units were down here times whatever units were on the y-axis. But you might be thinking, Ms. DeWald, that estimation stinks. Those are really big rectangles and don't really fit. So what would make it better? More rectangles. So let's go to the next page. If I have more rectangles, this is on 159. Be careful that your pages don't get mixed up here just because all these figures look the same. This is still the same graph. This is still f of x. I'm still doing a left Riemann sum. But in this one, I'm doing a length of 1 unit. So I'm still going from 1 to 7. And it is really important you actually draw this in here. I'm still trying to find the same area as before, where we shaded this before. It was 1 the whole way over to 7 between the x-axis and this curve. But how I'm going to do this time is make a bunch of rectangles more than before. So now I'm going to go a left-hand Riemann sum, means that my left side will touch the function. That's my new height. But here I only have a base of 1. My next rectangle is going to start at x equals 2 this time, go the whole way up until I touch my function. Okay, fill in the rest. Should have brought more colors. Next one be 4, touches here. Start over on my colors. And one more because I have to go the whole way to 7. I just went in the wrong order, but that's fine. I mean, just with my colors, doesn't matter. Okay, so here I'm going to try to say, okay, how do I find the area of all those? It looks a little bit better than before. It looks like it's starting to become that shape. There's an overestimate here, but an underestimate here. To find the area of all these things, I would have to do the same thing as before. 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4, 1 times f of 5, 1 times f of 6, and that's it. I could just put 1 on the outside because I'm multiplying. This is the same width for all of these. So 1 times f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6. Because this is always the base. This was the height of each of these rectangles. And I can see right here, there's 1, 2, 3, 4, 5, 6 rectangles. 1, 2, 3, 4, 5, 6 different heights and different function values here. If I multiply these things out, f of 1 is 20 over 3 plus f of 2. You can go back up to this f of x and substitute in this in 23 over 3. F of 3 is 8. F of 4 is 23 over 3. F of 5 is 20 over 3. Some of these we know from the last page too. F of 6 is 5. Multiply all this together. The left Riemann sum is this whole area, which ends up becoming 41.667 square units. Whatever those units might be, it's always going to be the length times the width. So it's the base, whatever that is, the units for the base for the x values and for the y. Okay, let's do more. And you might say, that's not good enough. So how could you make it even better? Well, why not? More rectangles. This is a left-hand Riemann sum with a interval the length of a half unit. So I'm still doing the same thing as before. But this has an interval of a half unit. So I'm still going from 1 the whole way over to 7. That's what's given here. It's in the interval from 1 to 7. But here, you're still doing the left. So I'm still going as high as the left. The only thing that's changing, if this is an interval of a half, I'm making more rectangles. You try it. I'm going to use all the same colors this time. You should be doing this too. Don't just watch me and be like, yeah, I get it. Because some of this is just practice from doing it for a while. There we go. And it's getting better. And how could you make this even better? More rectangles. Don't worry, I'm not going to make you go into a fourth or a third or a third's bigger. A fourth or an eighth or a 16th or something like that. Like this is enough for you to get the idea. That the first one wasn't that good of representation because we only had the length of a rectangle was 2 units. But what if we could put an infinite number of rectangles in here? That's where we're heading. Don't worry, you're never going to have to draw an infinite number of rectangles because that's impossible. But here we go. We've got left-hand Riemann sum still. All of these have a length, or you could say a base of a half. But all of these rectangles now, I'm still starting at f of 1. But this would be f of 1.5 or f of 3 halves. This would be f of 2, f of 2.5, f of 3, 3.5. This is going to look gross, but I'm running out of room. F4, F4.5, F5. Make sure you don't go too far on this. Think about where you're going to end it. Even though my interval ends at 7, I'm not going to end this at 7 because I've got a left-hand Riemann sum. There was no function value starting at 7 for my rectangle. If I go through all these, well, this is a lot, but we're going to do it. This was 1 unit. There we go. If you want to skip to the answer, feel free. But f of 1, 20 over 3. I'm actually at f of 4.5. Okay, I think I got all of these ones. Oops, here we go. So if you, there you go. If you got this and you feel comfortable with that and you just want to skip to the answer, you can do that. The answer for this one is 40.916. It's actually repeating if you want that, but you only need 3 places after the decimal. That would be the area for this one. So I'm getting closer and closer and closer. But you might be asking, why do we start at the left? Why not do it to the right? And why not? We just did left-hand Riemann sums. Hold on. So you might be asking, we did left, why not do it to the right? Let's do that. This is a right-hand Riemann sum. So it's very similar, except when you're thinking about what is the height of whatever rectangle you're putting in, you're not going to be looking at the left side anymore. You're going to be looking at the right. So I'm still going from 1 until 7. This is still my interval. I'm still trying to find what is the area of that whole region. It's under the curve, but really between the curve and the x-axis. But when I make my rectangle with a length of 2 units, I'm going to be choosing my height by going to the right. Then I'm going to do the same thing in the next one. I'm going to be going 2 units, choosing my height by going to the right. 2 units, going to the right. This is a terrible underestimate because you can see there's a big hole here. It's barely above there, but whatever, we're going to go with it. This is just one way to estimate. I didn't say it was a good way yet. So for this Riemann sum, the 2 is the base, and then the height would be, I would start with f of 3, and then it would be 2 times f of 5. So I'm just factoring out the 2 in the first place. If you want to rate it up above 2 times f of 3, 2 times f of 5, you may. 2 times f of 7. F of 3, I'm putting each of these values in there. If I multiply all these things out, this one is 34.667 square units. Whoa, way less than the other ones, and it's the same region. How can we make it better? More rectangles. What? People are going to be hearing you screaming and be like, more rectangles! And they're going to come and join you in that because they're like, yeah, the world needs more rectangles and fewer squares. Squares, get it, because people, that's a nerdy term. Just kidding. Okay, 162. Let's do this. Approximation number 5. Can you believe we're already there? Right-hand Riemann sum with a length of 1 unit. Same thing as before. You draw. Okay, check yours with mine. And this one, I would have to take, these are all 1 unit, so it'd be 1 times, the first thing that I'm starting at in this one would be f of 2. Make sure. Oh yeah, the last one was f of 3. So this one would be f of 2, 1 times f of 3, f of 4, f of 5, f of 6, and the whole way over to f of 7. Substitute a bunch of stuff you know. I'm going to write this down below. But if you need to just skip to this part because you're like, I've got this, I can't take any more rectangles, feel free, skip ahead. think you got all of them, and you should if you multiply all this out. Still less than we were getting before. That's okay. And you're thinking, how do I make this even better? More rectangles! This is where you might be like, I get it. And you can just do enough that you get, this isn't going to be the whole way. Oops, sorry. If this is a right Riemann sum with a half unit, you're going to only be going halfway over. And then remember to choose your height by the right hand side. So the base in this one is going to be a half. The height, my first height, would be f of 1.5. I'm going to draw the rest of them. You can too, or you can jump to the end in this one just because I feel like you've got the idea. Make sure all the right hand sides are touching. The whole way to 7. This is going to start at f of 1.5 and never go 1.5 until the whole way we get to 7. If you multiply all these things out, I'm still on the length of, there we go. If we're doing a length of a half here, this is the area of each one of these things. It would be the same as 1/2 times each of these parts. I'm just taking the 1/2 out in front. You should get, after all of this, 38.916 units. Well, it would be unit squared. It would be whatever this unit is times whatever this one. So I'm going to stick with this. And just in case you want this, remember you can go back up to the other function. Just in case you wanted all those values. There they are. But you don't have to write them down. Okay, and you're probably like, enough with the rectangles. No problem. Actually, not no problem. No problem in a minute. You're probably like, enough with the rectangles. Not quite. Because you might be saying, well, why would we do a left-hand Riemann sum? Because that seems like an overestimate. Or a right-hand Riemann sum, because that seems like it's going to be an underestimate in this case. What about if we did a midpoint Riemann sum? What is a midpoint Riemann sum? Has a length of 2 units. I'm going 2 units here. When you're talking about the height of a rectangle, you should be looking at whatever this middle value is. So if my rectangle is from x equals 1 to x equals 3, my height is going to be at x equals 2. So I'm going, the middle of my rectangle is right here. So this is what a midpoint Riemann sum is. A Riemann sum is just a rectangle, like you're taking a bunch of rectangles, filling in a space to estimate the area under the curve. A midpoint, the height is determined by the midpoint of whatever the base is. So here, just like before, it would be 2 times, but now it's going to be f of 2 because that's the middle. If I do another one, now I'll even write it out. 2 times f of 4. And then this one, this height would be in the middle. Oh, this is hard. I'm sorry. I went over it this way. F of 4 should be the height of this one. Should be right there because that's the midpoint. At 4, it's hitting here. Should be 2 times F of 6. You can keep the 2 out in front. And you get for this one 2 times, this is F of 2 is 23 over 3. Oh, F of 6 is 5. And you might be saying, okay, that's nice because it's a midpoint, but that's not quite good enough. Maybe if I made more rectangles. Good news. Good news for you asking for more rectangles. What? Hey, Caleb. A little bit quieter in the middle of a video, okay? Thanks, buddy. Okay, so back to it. This is on 165, and it's saying a midpoint Riemann sum with a length of 1 unit. So I get more rectangles. Woo! Same idea. I'm still going from 1 to 7. It's kind of nice to write that off first. If I do a midpoint Riemann sum, but it's only 1 unit, my midpoint would be up here. So draw on all the rest. Okay, midpoint. So there they are. And then I would take what is my length of my rectangle or my base of my rectangle, which is 1. And all of these, and it's 1 times, and every single time it's the same. Or you can say 1 times each one, or you're like, I don't really need to multiply by 1 at all. That's fine. But remember, this would be like F of 1.5, F of 2.5, F of 3.5. My last one is at F of 6.5. Make sure that you didn't go too far and say, well, this is F of 7.5 or 7. It would just be the midpoint. So 1.5, 2.5, 3.5, 4.5, 5.5, 6.5. That's it. If you do all the calculations for this, I think we've actually listed all these so far before. So should be okay. These are all on previous pages if you want these things, or you can go up to here for F of X. But you should get 40.16. Actually, here. Definitely do not have to write these, but just in case you want them, there they are. Okay, and then how can I make this better? More rectangles? So sad. I'm not going to give you more rectangles right now. We're going to move on to a different shape. We're estimating with rectangles, but that's not the only thing we know. What if we did this instead, and we did it with trapezoids? So if you were zoning out because you're like, I'm sick of rectangles, come back. This is totally different shape. Same sort of idea, but sometimes people have more trouble with like remembering what the formula for trapezoid is, so come back to me. This is still estimating from 1 to 7, the area under the curve, so still that same shaded region. But this is a trapezoidal Riemann sum, which means that we make trapezoids. If it just says Riemann sum, we make rectangles. This is a length of 2 units. So most people, when they think of trapezoids, they think of them like this, like a Pizza Hut sign or something. These two sides are parallel, the other two are not. The way that we're going to do this is think of more trapezoids like this, where these two sides are going to be parallel to one another, and then these are going to be something different. Or in this case, more appropriately, the base is always going to be the same, and this might be going either direction, but these two sides would be parallel. With that being the case, this area formula you probably learned a long time ago is that. Or sometimes you might see it as base 1 plus base 2 divided by 2 times that. You might see it like that. Sorry, the lighting's doing something weird. But this is the area formula. But when I think of base 1 and base 2, it's normally like this. The difference in thinking here is that base 1 and base 2 are not going to be on top and on bottom. Base 1 and base 2 are going to be here. And the height, I normally think, is the one that's perpendicular to whatever the base is. Same idea. If this is perpendicular, this can be the height. Okay, so let's work through that. What does that mean? I'm going to keep that kind of up there. This has a length of 2 units, or in this case, it's my height. My h is 2 units, but I'm going to say it's from here to here. When you make a trapezoid, it goes the entire way up to wherever the function is. Same thing at 3. And here's one of them. I'm going to just leave it right there and find the area of just that one. So it's 1/2 base 1 plus base 2. Remember, the bases in this are not going to be like how we traditionally think. It's going to be more like this, base 1 and base 2. So this base 1 and base 2 would be f of 1 and f of 3. 1/2 base 1 plus base 2. My height is always perpendicular to whatever my base is. So here my height is 2. Okay, let's do the next one. If I go from 2 units (1/2), my base 1 would be here or here, doesn't matter which one, so f of 3. My base 2 is going to be f of 5. And my height is perpendicular to that base, 2. The next one would be (1/2). Base 1 would be this one, f of 5. Base 2 would be f of 7. My height is perpendicular to the base, which would be 2. Because these are all multiplied by 1/2 times 2, 1/2 times 2 is just 1. You could factor that out like a 1, but you don't even really have to. So it's really f of 1 plus f of 3 plus f of 3 plus f of 5 plus f of 5 plus f of 7. If you do all of that work, and again, you can use the function that was given here and substitute in, but I think by this point you're probably kind of sick of this. And the answer to this one, if you do all of this work, is going to be 38.667. Just in case you want this. Oh wait, f of 3. So just in case you want it, these were the values. But how could we make this better? This estimate, it looks pretty good. It's an underestimate. More trapezoids. Last page, we did it, we're here. Okay, consider for a moment this function. This says a trapezoidal Riemann sum with length of 1 unit. So my trapezoid, if you remember from the last page, be 1/2 base 1 plus base 2 This would be base 1. This would be base 2. That's coming the whole way up to f of 1 plus f of 2. What would be the height? It's always perpendicular to the base. This is a 90-degree angle. So this is just 1. Do the next thing, 1/2. Base 1 plus base 2. So go through and draw the other ones or do it one at a time, whatever you need. I'm going to draw them in first. That looks really great. Can you imagine if we had it for a length of half unit or something else? But either way, this is the last one we're going to do, sadly. But 1/2, instead of f of 1 plus f of 2, this one's going to be f of 2 plus f of 3. My height is still 1. Okay, I'm going to keep going. You should too. Okay, check yours. See, do you have something similar to that? I can see that my f of 4 is the same as my right side of my trapezoid is the same as my left side here. That's how I know to keep going. Okay, you do all this work, multiply it out, you get, hold on, that was with 2 units. It might be slightly an underestimate here, but it's getting better and better and better. If you want to know all these other values, you do not have to write all these, but just in case you want to know them, so you can check in case you did any of this on your own. That's it. Okay, so lots of rectangles, lots of trapezoids. Thanks for sticking with me. I appreciate you. Bye.